Okay, in g of x, we have x squared minus 5 as long as x does not equal 0. And we have 4 if x does equal 0. So essentially, does x equal 0 or not be 0? In which case, we know which equation to go with. All right, so g of negative 3. G of negative 3, do I want the top or the bottom? And since it clearly is, so negative 3 does not equal 0, I want the top. So something squared minus 5. And we'll fill that hole in. What's negative 3 squared? That's 9 minus 5, and I get a 4 out of that. All right, brings us to the next one. G of 0. Well, 0 does in fact equal 0, which tells me I'm going to use the bottom equation. So that would be 4. And the last one, g of 3. Well, 3 does not equal 0, so that means I got to use the top one. So something squared minus 5. So 3 squared again is 9 minus 5, and I get a 4 out of that. So it turns out I get 4s all over the place. Alright, so if we want to graph a piecewise, here's what we're going to do. So to graph a piecewise defined function, we're going to choose several values for each domain, including endpoints, if any. If any, and then whether or not that endpoint is included in the domain. We're going to label each endpoint as closed or open, so label each endpoint as included or not. Okay, again, reminder, that's just whether it's a closed or open circle. And then we're going to sketch the graph based on the ordered pairs that we find. Okay, so coming down to our cell phone plan, we have, do we have any endpoints? Let's first identify those. And the answer is yes, we do. We have 0 and 60 on each interval, okay, which means for the top equation, there's an ordered pair 0, comma something, and there's a bottom equation with 60, comma something. Hold on, bear with me here. Okay, and in the bottom equation, there's also an ordered pair for 60, comma something. Okay, so in the top equation, it says of 0, I'm going to put a 20, so it's 0, comma 20. 60, so it's less than or equal to 60, it's also going to be 20. Both of these are included. Okay. Here, with the other one, so if I want to figure that one out, that would be 60, comma 20 as well. So if I plug a 60 in, 60 minus 60 gives me 0, and 0.4 times 0, I get 20. And it's not included. Which brings a minor issue up, but we'll address that. Okay, so I see that this particular table has got two equations, either the top or bottom. So I'm going to split my table in half. And half of my table is going to be based on this idea of 20, and half of it's going to be based this idea of 20 plus 0.4 t minus 60. Now, I already know 0 and I know 60, so let's get somewhere in the middle between 30. And I know that this also has a 60 in it, and I know that one's open and that one's closed, and this 0 here is closed. Okay, so I need something like 70 and 80. I just need to know a little bit more about what's going on past the 60. Okay, so let me go back and let's just have this talk out loud to myself about open versus closed. If we include that point in the graph, it's going to be a dot in the graph. If we don't include it, it's going to be an open circle. Okay, now in this particular example, we do have this minor issue of an open and closed circle on top of each other. Okay, when we get to the graph part, when we get to actually putting it in the picture, we'll come back and address that particular issue. But for now, we'll just sort of fill in our table here. Okay, so for the top part, anytime any x value I put 0 in, I'm going to get 20 out, get 20 out, and get 20 out there. So I know what that looks like. That looks like the flat horizontal line at a y value of 20. Down below, I have 20. So that part we already figured out was 20. But I want to know what about when it's 70. So 20, maybe I want to give myself a little more room here to write. So 20 plus 0.4, 70 minus 60, and I'm just going to go to a calculator and just type that in real quick. So 0.4, so I get 24. And then same thing with the 80. So 20 plus 0.4, 80 minus 60. So 20 plus 0.4 times that, and I get 28. Okay, so I can kind of see that it seems to be going up by 4. So I'm guessing I should get 32 out of that. And in fact, I do. Okay, so I can see already what's happening here. That for every 10 minutes I talk, it's going to be an extra $4. Okay, so now what I want to do is I want to put that graph, that table of values, on this graph. Okay. I know what happens at 0. I know out to 60 there's something interesting. Let's see, so we'll go 70, 80, 90. That's what I have labeled in my chart there. And then going up, looks like I don't have to go up too far here, so we're going to go up by 5s, 10, 15, 20, 25, 30, 35. Now I just picked a number because I knew how far my chart had to go up, and I saw a lot of my y values are hanging around 20, and at least I had to go up to 32, so I just needed to make sure that I had something on my chart that went from 0 to at least 32. Okay, so what I'm going to do then is I'm going to plot points. So I'm going to connect, let's see, I'm going to connect the top 3 together. So I've got 0, 20, I've got 30, 20, I got 60, 20. Okay, and all of those are going to be connected together. Now, we go to the bottom part. My first point, 60, 20, is an open circle, but here's the question. If there's a close point and an open point on top of each other, could I tell? Right? Now, it's kind of like if someone, imagine you're staring at dirt. Someone a week ago dug a hole and somebody else filled it up, and now you're staring at the ground. Could you tell there's a hole there? You know, again, it's dirt, not grass. I realize that there'd be a dead grass. That's not what I'm saying. I'm saying someone digs a hole and fills it in, and you're staring at dirt the whole time. Could you tell that there's a hole there? And the answer is no. So graphically, if we have an open circle on top of a closed circle, we wouldn't be able to tell. So I'd still see a point there, but mainly because of the previous set of points that I drew. All right, then I want 70, 24, and I want 80, 28, and I want 90, 32. Okay, and I can kind of see what's happening here, that it's going to be a diagonal line with a slope of 4, and it's going to keep going on forever. That's going to start there. Okay, and so that is a picture of this particular graph. That's a representation of how much my cell phone bill would cost as I talk more and more and more. So first step is to identify any potential borders, any potential endpoints that define open and closed circles. So in this graph, I go straight to the domain statement, and I see zeros where all the fun stuff is. So I know it's 0, something and 0, something. And if I evaluate it, I get 1 plus 0, which is 1. So I get 0, 1. And here I get 0 squared, which is 0. And then I'm going to look at the symbols. And the symbols, that one says less than, so that's open. So it's not included in the picture, but it is an ordered pair in the picture, but we don't put a closed point on it. And the other symbol says greater than or equal to, so I want to put a closed point there. Okay, so then I'm going to make a table of values. And since I've got two equations, I'm going to split it in half. And the top equation I'm going to label as 1 plus x, and the bottom one is x squared. And I can see that 0 seems to be this point, seems to be the ordered pair where it switches from top equation to bottom equation. So I'm going to label 0 there. And I already know those two numbers, I figured those out. And I know that particular point is open and that point is closed. And so now I'm going to pick some numbers around it. So before 0, I must have been at -1, and I must have been at -2. And after 0, I must have been at 1, and I must have been at 2. And then I'm just going to figure it out. I'm just going to evaluate each of these numbers into my functions and figure out what the y values go with them. So that's 1 plus -2, 1 plus -1. Get some numbers there. Here we have 1 squared, and here we have 2 squared. Okay, so 1 plus -1 is -1. 1 plus -1 is, sorry, 1 plus -2 is -1. 1 plus -1 is 0. That would be 1, and that would be 4. Okay, so then I'm going to plot points, and I'm going to connect all the points that are from the same equation together. And I'm going to start with that open one. So let's see, it's open at 0, 1 right there. And then at -1, 0. And it's only open at that one point. Everything else is closed. I've seen students just open everything, and that's not the case. Then -1, sorry, -2, -1. And I can see that if I keep going down, it's going to be dotted lines, or it's going to be lines on the diagonal there. And so I want to connect all of those together. So that piece looks like that because it does keep going. And then I want to look at the other half. The other half, 0, 0, and that's closed. Then 1, 1, then 2, 4. And so I can see it's going to be this little curved parabola type thing on that side. And so that's a picture of that graph.